Seventh example. So here we have a 48 ohm resistor. 2 ohm resistor and a diode. In volts. Now here the question is to find the current through each element. Find the current through each element. So the first step is to find out whether this silicon diode has sufficient voltage to get forward biased. Okay, so let's find out voltage without the diode. Voltage without the diode. So that is going to be V dash is equal 2 over 50 into 10. So if you simplify, you get 0.4. But we know that 0.4 V dash is less than 0.7. Thus, the diode is not forward biased. The diode is not forward biased. If the diode is not forward biased, then current through this is 0. So current through both of this is going to be same. We are going to have the same current I flowing through both the resistors. So we can find it out easily. Therefore, 10 is equal 50I. I is equal to 0.2 amperes. That is equal to 200 milliamperes. Okay. You have to find the current through the diode. Okay, I hope you all can remember this step. The first thing is to find out whether there is sufficient voltage to forward bias this. If there is sufficient voltage, again you will mark the voltage according to that and find out the current. I'll give it a try. Have you all got these answers? Is it clear what is happening here? Yeah, and Shaham. Okay, done. Find the current through the diode. Find the current through the diode. So the first step is to check whether this diode is forward biased or not. So let's look. This is silicon. So without diode, VA is equal 8 volt and VB is equal 6 volts. VAB is equal to 2 volt. VAB is greater than 0.7 voltage. Therefore, diode is forward biased. Therefore, diode is biased. Now, to find the current, we will have to use the nodal analysis because any other method is hard. Okay, to find the current using any other method, it is hard. Let's try using the nodal analysis. So now with diode, we know that across this, how much voltage will drop? Across this, 0.7 will drop. So if this is V, if this voltage is V, this has to be V plus 0.7. V plus 0.7. Now, how many unknowns do we have? We have only one unknown to find. Okay. So, what else we can do? Can you remember nodal analysis? In nodal analysis, what we were doing is we were actually equating the current. Right? We were equating the current. Here, let's say current through this is I1 and current here is I2 and this is I3. This is I4 and I5. So here, what can you tell about I3 using nodal analysis? Using KCL. Using KCL, I can write I3 as I3 is equal I1 minus I2. Okay, there is one equation. Also, I can write I3 as here I3 plus I4 is I5, right? I3 plus I4 is equal to I5. I3 plus I4 is I5. Therefore, I3 can be written as I5 minus I4. That is the second equation. So both of them are equal, right? From 1 and 2, I1 minus I2 is equal I5 minus I4. Using nodal analysis, we can write this voltages, this current in terms of voltage. Using nodal analysis, we can write I1 as 10 minus V plus 0.7. 10 minus V plus 0.7 over 2 minus instead of I2 I can write V plus 0.7 over 8. V plus 0.7 over 8. This is equal, instead of I5 I can write V over 6 minus 10 minus V over 4. Now in this equation, the only unknown is V. Okay. The only unknown is V. Let's simplify. What is the least common? What is the least common multiple here? 24, right? Let's multiply the entire equation by 24. We got 6.78 voltage. So now you know the voltage. As you know the voltage, now you can find the current I1 and I2 and find what is I3. Let's find out what is I1. I1 is equal 10 minus 1.26 milliampere. And I2 is equal 0.325 milliamperes. That is the current through the diode. Okay, once you have noted, let me know. Done. Idea is clear, right? You might not be getting these types of tough ones, but sometimes you might get questions where you need to solve using nodal analysis. In the past papers, you might not find, but recent papers you might get. Okay. In the pressure book, there are questions. You can try the questions by yourself, and you can ask the questions you have doubts. Okay. Let's continue the theory and later try those questions. So next topic, LED, light emitting diodes. Light emitting diodes. So in light emitting diodes, don't try it. First, I'll explain what is happening. After that, let's write the note. Okay. Uh, the light emitting diode, you might have seen these LEDs. So in these LEDs, there are two terminals. When you look closely, one of the terminal is like this. So the positive terminal is a little longer than the negative terminal. So here, in diagram we show it like this. A diode with arrows going out. That means it is emitting light. Current will flow in this direction and it acts like a normal diode. Here Vs has to be greater than V. V is the forward bias voltage. So just like a diode, just like a normal junction diode, This one also has the same characteristic, same mechanism. Okay, it works in the same mechanism. Here you have the p-type semiconductor, n-type semiconductor, where the p-type is connected to the positive terminal and n-type is connected to the negative terminal when they are forward biased. Here what's special is in this junction we have holes and electrons. We have holes where when electron falls into these holes, they release heat plus light. In a normal diode, it will only release heat, but this diode releases light with heat. That is due to special compounds. Okay, so draw these three diagrams quickly. When current passes through the diode, passes through the LED in forward bias, it emits light. Special compounds are added to the diode to make holes with higher energy state, with higher energy state at the junction. When electrons are captured by these holes, when electrons are captured by these holes, they release heat plus light, heat and light. So the only difference between a normal diode and a light emitting diode is this. It has special compounds where the holes have higher energy state. So it will release more energy, where part of the energy is heat and the remaining energy is light. Okay, that's the only difference between a normal diode and a light emitting diode. Normal diode only release heat. Normal diodes only release heat. To obtain different colors, now you should have the idea that special compounds are responsible for emitting light. Then the colors They are also different energies, right? It depends on the energy. The color depends on energy. That means the color is going to depend on the compound we add. So different compounds are used to obtain are used to obtain different colors. Not LEDs are cheap. LEDs are cheap and small in size. And nowadays used in variety of applications. Not number two, 2014 Nobel Prize in physics was given for the discovery of efficient blue LEDs. Okay, done. If I need to scroll up, let me know. Next topic, photodiodes. photodiodes. So the photodiode is opposite of LEDs. They absorb light and convert it into uh, electricity. So this will be the symbol for photodiode. And it is connected in reverse bias, not forward bias. So we connect a photodiode in reverse bias. Therefore, the depletion layer widens. And negative terminal of the battery is connected to the P region, and positive terminal of the battery is connected to the N region. And here you have plus, minus. We will have electric field set up in this direction. We will have an electric field set up in this direction. Now here, what happens is when light falls on the junction, when the light, we know that is photons, right? When photons fall on this junction, they uh, emit electrons. The electrons absorb that energy and it comes out. So a hole also will be, when electron comes out, a hole will become available, right? Now, it is in the electric field. This electric field will push this electron to this side and the hole in the opposite direction. Due to this hole, there will be a current towards your left. Due to the movement of electron also, you will have a current towards your left. So, a current will flow in the circuit in this direction. Okay, a current will flow in the circuit. Draw this diagram.